Hello everyone, welcome back to channel. I am Nikhil Kumar. In the last video, we understood how Linux networking works internally. Today, we will use the tool you actually run during the production incident. Because in real life, nobody asks, do you know networking? They ask, can you debug it? And I will show you every command with a real working demo so you can repeat everything on your machine. But before commands, remember one thing. Each tool answers one specific question. Is the service responding? Can I download something? Does DNS resolve? And where does the traffic stop? We never run commands randomly. We run them with an intent. So let's start with the first question. Is the service actually responding? For that, our main tool is curl. Curl is the most important networking tool for DevOps. Why? Because curl talks directly to your application, not just the network. So for the demo purpose here, I am going to use google.com because it's always available. It's HTTPS enabled and it's having a predictable response. Now let's test the basic curl here. So we have a command that is curl https www.google.com. So if I hit enter, so it gives us a response. If you see the HTML coming back, this confirms the DNS got resolved, routing is working fine, and port 443 is open, and application is responded. One command and 4 validation. So that means our application is working fine. Just now I tested with the google.com because the application is always running and is always available. But in production, we usually care more about status code than the response body. And to check that, in the curl we have a different option. So curl-i and google.com. As you can see here, it gives us a status code that is 200. That means it's okay. But in different scenarios, if our application is sending a different status code like 301 or 302, that means it's redirecting it. If we are getting 401 or 403, that means authentication issue. If we are getting 500, it means server side problem. These codes instantly tells you where the issue is. Now let's test the application which is not available right now. Let's check how the curl is responding for that. If I run curl https localhost and 9999. So this fails with the connection refuse, meaning the network is fine, but there is no application listening on that particular port. So that means we are not having any application which is serving on that particular port number. So the curl tests the services. But what if we want just to download something quickly? So for that case, we have a wget. Wget is simpler than curl as it's mostly used for downloading files or quick connectivity checks in the script. Now let's download a page from the Google. So if I use wget and the google.com, so if I press enter, right now I don't have a wget install in this, so let me install it very quickly. So yum install wget. Now the wget got installed successfully. Let's run the same command again. This works fine. It confirms several things at once. The DNS resolution works, routing works, and the HTTPS connectivity also works. In CI/CD pipelines and automation, wget is often preferred because it's simple and script friendly. Now I want to give you a quick rule to avoid confusion. Curl is used where we need to talk with the APIs or debugging services, but wget is used to download files or mirroring content. So we use the right tool for the right job. So services access works, downloading works, but what if the name itself doesn't resolve? When something fails, DNS is often the silent culprit. And to answer that particular question, we have a tool for that. That is dig. So dig answers only one question. Does this name resolve to an IP address or not? So let's test the Google DNS here. So if I use dig and the Google DNS name here, google.com. If I hit enter, so you don't need to read everything here. You just need to focus on the answer section here. If you see IP address is coming, that means the DNS resolution is working fine. Now let's test the wrong DNS name. So if I run the dig command against the not available DNS name, so if I hit enter, so we got a response here. That means the DNS itself is working, but the name does not exist. This restriction saves hours in production. So DNS works, networks works. Now where exactly the traffic travels? So to debug the path of the network, we use a traceroute. So the traceroute shows the path packets attempt to take across the network. It answers one specific question. How far does my traffic go and where do replies stop coming back? So let's trace the traffic to Google again. So if I use traceroute and google.com. So if I hit enter, each line here represents one hop. That means routers, gateways, and network devices between you and the destination. So if you see multiple stars here instead of router names, don't panic. Many modern networks and cloud firewalls block traceroute replies, and that does not always mean the network is down. Sometimes the router is reachable, but it just doesn't reply. Traceroute suddenly stop responding. The common reason are firewall rules, routing restrictions, or cloud or network security policies. This tool is gold when we need to check if an application is working in one environment but fails in another one. That usually means the application is fine, but the network path is different. So the traceroute tells us something very important. It doesn't just say something failed, it shows where the failure begins. And many times you will notice this pattern. The application is perfectly fine, but the network path is different. Now here's the problem. Most people stop here and then they start guessing. This is exactly why DevOps debugging needs an order, not a random commands, a proper flow. Now let's connect everything like a DevOps engineer. When something doesn't work, we don't panic. We narrow it down step by step in the same order each and every time. So today we have learned curl to test the services and status code, wget to download and check connectivity, dig for DNS debugging, and traceroute for path analysis. This is the daily DevOps tool. In the next video, we are going deeper in the running storage, where we will see how pod writes data, how disks are mounted, and why storage problem often ends up breaking your application. If you found this helpful, hit like, share it with your friends, subscribe for more content like this. Thanks for watching. I will see you in the next one.